Assalamualaikum and hi everyone. Now you are watching 1.1 reaction rate video 3. In our previous video, we already discussed about reaction rate, graph concentration versus time, and differential rate equation. In this video, we will focus on rate law or rate equation, order of reaction, and rate constant. First, we need to understand about relationship of rate, rate constant, and orders of reaction. Changing the concentration of substances taking part in a reaction usually changes the rate of the reaction. Rate is proportional to concentration of A. A here is the substances taking part in a reaction. So, in mathematical expression, it can be written as rate is equal to K times concentration of A, with K is the rate constant. Its units are molar per second or mole per dm cube per second or mole per liter per second. Next, we proceed to the rate equation or rate law. Rate equation or rate law is the relationship of the rate of a reaction to the rate constant and the concentrations of the reactants raised to some powers. Rate equation or rate law can be written like this. Rate is equal to K times concentration of reactant raised to the power of X. Rate here is rate of reaction, K is rate constant, concentration of reactant is this one, X is the powers. X here is the order of a reaction. Order of reaction is the exponent value of concentration of reactants in the rate equation. Recall back on the rate equation or rate law. Which one is the order of reaction? The order of reaction is X. Okay, let's continue to the order of reaction. The value of order of reaction must be determined experimentally and can be in the form of an integer or a fraction. The order of a reaction is not related to the stoichiometric coefficient of the reactant in the balanced chemical equation. And the last one, in this syllabus, we shall discuss the value of order of reaction of 0, 1, and 2 only. After you have understand about rate equation and order of reaction, now we will learn about how to write the rate equation or rate law. For a single reactant, for example, we have equation AA produce product. So the rate equation is rate equal to K times concentration of A to the power of X, where concentration of A is concentration of A in molar. K is the rate constant. X is the order of reaction with respect to A. Bear in your mind, product is not involved in rate equation or rate law. If you have multiple reactants, for example, AA plus BB produce product, the rate equation is rate equal to K times concentration of A to the power of X times concentration of B to the power of Y, where concentration of A is concentration of A in molar, concentration of B is concentration of B in molar, K is rate constant, X is order with respect to A, Y is the order with respect to B, X plus Y is the order of reaction. Example, this one is the balance equation and the one in the blue box is the rate law or rate equation. From the rate law or the rate equation, we can identify the order of reaction. For NO2, since the power is 1, so it is first order with respect to NO2. F2, the power is 2, so it is second order with respect to F2. For overall order of this reaction, we must total up the order of reaction for NO2, which is 1, and the order of reaction of F2, which is 2. 1 plus 2 equal to 3, so overall order of this reaction is third order reaction. Next is rate constant, or the symbol is K. Rate constant is a constant for a reaction at constant temperature. Based on the rate law, rate is equal to K times concentration of reactant to the power of X. K is directly proportional to the reaction rate. That means when rate of reaction increase, the value of K also increase. Rate constant K has unit. Now let's learn how to derive the unit of rate constant K. Let's say the equation is like this. If the order of fraction is 0, the rate law or the rate equation is rate equal to K times concentration of A to the power of 0. To derive the unit of rate constant, we can see when concentration of A is power of 0, so it is equal to 1. So rate is equal to K. So unit of rate constant K is equal to unit of rate, which is molar per second. If the order of fraction is 1, so the rate law or the rate equation is rate equal to K times concentration of A to the power of 1. To derive the unit of rate constant, we must rearrange the rate law or the rate equation. So it will become K equal to rate over concentration of A. Unit of rate is molar per second and unit of concentration is molar. So we can cancel out molar and molar. So unit of K is per second. If the order of fraction is 2, the rate law or the rate equation is rate equal to K times concentration of A power of 2. To derive the unit of rate constant, we must rearrange the rate law or the rate equation. So it will become K equal to rate over concentration of A power of 2. Unit of rate is molar per second. Unit for concentration of A power of 2 is molar power of 2. So we can cancel out molar and molar. So the unit of K is per molar per second. Example. The above reaction is first order with respect to iodide ions and to thiosulfate ions. A. Write the rate equation or rate law for the reaction. B. What is the unit of rate constant K? To write the rate equation or rate law, we must know the order of fraction for each reactant. So, according to the question, it is first order with respect to iodide ions and to thiosulfate ion. That means thiosulfate ion is first order, iodide ion is also first order. So, the rate equation or the rate law is rate is equal to K times concentration of thiosulfate ion to the power of 1 times concentration of iodide ion to the power of 1. Next is unit of rate constant. This is the rate law or the rate equation. So we rearrange the rate law or the rate equation. It will become K equal to rate over concentration of thiosulfate ion power of 1 times concentration of iodide ion power of 1. To derive the unit of K, unit for rate is molar per second and unit for concentration of both reactant is molar power of 2. So we can cancel out molar and molar. So the unit of K is per molar per second. Thank you for watching.